On the 15th day of November in 1943, inside the fortified command bunker at Rabaul that housed the Imperial Japanese Navy's Pacific headquarters, Commander Masatake Okumiya found himself staring at a collection of aerial reconnaissance photographs that challenged everything he understood about military engineering. His hand had stopped moving midway across the intelligence report spread before him, his mind struggling to reconcile the images with what he knew to be physically possible. The photographs, taken by reconnaissance aircraft that had risked American fighter interception to capture these images, showed something that shouldn't exist according to every manual, every calculation, every principle that Japanese military engineers had developed over decades of experience. The Americans had somehow managed to complete fully operational airstrips on Bougainville Island, and they had done so at a pace that defied rational explanation. The images were clear and undeniable. Fighter aircraft were already operating from Torokina Field, their wheels touching down on runways that, by Japanese calculations, should still have been months away from completion. Even more remarkably, the photographs showed ongoing construction work on bomber strips, and this work was proceeding at what could only be described as an unprecedented velocity. The most stunning detail visible in these reconnaissance images was the presence of construction crews actively working on the runways even as American fighter planes took off and landed around them, weaving between the workers and their equipment in a display of organized chaos that seemed impossible. Okumiya lifted his eyes from the photographs and gazed through the reinforced window of the command bunker. Outside, in the harsh tropical sunlight, he could observe Japanese construction crews engaged in the exhausting labor of repairing damage to Rabaul's own runways, damage that had been inflicted by American bombing raids that had occurred weeks earlier. 300 men had been assigned to this repair work, and they had been pushing themselves through 16-hour shifts for 5 consecutive days. Despite this extraordinary effort, they had barely managed to fill in the craters created by a single bombing raid. The contrast was almost too stark to comprehend. Here, at one of Japan's most important Pacific bases, highly trained crews struggled for days to repair what American bombers could destroy in minutes. Yet these photographs from Bougainville showed that the Americans had somehow carved functional airfields directly out of virgin jungle, and they had accomplished this feat while simultaneously enduring intermittent Japanese shelling and air attacks. Thousands of miles away, in the German capital of Berlin, a similar sense of disbelief had taken hold of the German General Staff. Colonel Hans von Greifenberg, who held the position of head of the Wehrmacht's Foreign Armies Intelligence Section, found himself poring over reports that had reached German intelligence through various channels. These reports had filtered in through neutral Swedish diplomatic channels and through observations made by Spanish merchant marine personnel who had visited Pacific ports. The intelligence painted a picture that seemed almost fantastical. According to these reports, the Americans were constructing complete airbase complexes on remote Pacific islands, and they were doing so in time frames that violated every fundamental principle of military engineering that the Wehrmacht had studied, taught, and practiced. The reports seemed so far beyond the realm of possibility that numerous German officers had simply dismissed them as Allied propaganda, as psychological warfare designed to demoralize Axis forces and overstate American capabilities. What neither Commander Okumiya in his bunker at Rabaul nor Colonel von Greifenberg in his Berlin office could have known at that moment was that they were actually witnessing the most revolutionary transformation in military construction capability that modern warfare had ever seen. The United States Navy had created specialized construction battalions, units that would become known by the nickname Seabees, and these units were in the process of fundamentally rewriting the mathematics of warfare. They were achieving this transformation not through the deployment of superior firepower, not through the implementation of brilliant strategic innovations, but rather through the systematic application of bulldozers, coral-crushing machinery, and an industrial efficiency that drew on America's vast experience with large-scale construction projects. This industrial approach to military construction would systematically dismantle Japanese defensive strategy across an area spanning more than 4 million square miles of Pacific Ocean. The revolution that would reshape Pacific warfare had actually begun in disaster on the 7th of December in 1941. On that date, which would become infamous in American history, Japanese forces launched their surprise attack on Pearl Harbor. Simultaneously with that devastating strike, Japanese military units attacked Wake Island, where approximately 1,200 American civilian contractors had been engaged in building military installations for the United States. The situation these civilian contractors found themselves in highlighted a critical vulnerability in existing military planning. Under international law as it was understood and applied at that time, civilians were not permitted to resist military attack. Those civilians who chose to take up arms against uniformed military forces faced potential execution as guerrillas or unlawful combatants. 98 of these American civilian workers were murdered by Japanese military forces in the aftermath of Wake Island's capture, and their deaths served to underscore a critical weakness in America's overall Pacific strategy that had relied heavily on civilian contractors for base construction. Rear Admiral Ben Morrell, who served as Chief of the Navy's Bureau of Yards and Docks, grasped the implications of this situation with immediate clarity. He understood that modern warfare as it would unfold across the vast Pacific theatre would require the construction of hundreds of bases scattered across thousands of individual islands. Civilian contractors working at these remote locations would be virtually impossible to protect adequately, and they remained legally prohibited from defending themselves when under attack. On the 28th of December in 1941, a mere 3 weeks after the Pearl Harbor attack, Morrell formally requested authorization to create militarized naval construction battalions that would combine construction expertise with military training and legal combat status. By January 5th of 1942, he had received approval to begin recruiting men directly from the construction trades for military service. The acronym CB, derived from Construction Battalion, rapidly evolved into the more memorable nickname Seabees. And with this organizational innovation was born a military force that would ultimately prove more devastating to Japanese strategic planning than any battleship task force or bomber squadron could have been. The recruitment process for these new construction battalions was unlike anything that had been seen previously in American military history. Men ranging in age from 18 to 50 years old, with some who had lived and worked in Pacific territories actually lying about their age to enlist despite being older, were brought into military service based on the skills they had acquired in civilian life. They brought with them expertise from every construction trade that existed in America at that time. The ranks of the Seabees included carpenters skilled in every aspect of woodworking, electricians who could wire anything from a single building to an entire base, plumbers who understood water systems and sanitation, heavy equipment operators who could handle the massive machinery that would become central to Seabee operations, professional engineers who could design complex facilities, surveyors who could lay out construction projects with precision, and demolition experts who knew how to remove obstacles efficiently. The average age of Seabee recruits was 37 years old, dramatically older than the typical military recruit of that era. These were not young men fresh out of school. These were experienced professionals who had built America's towering skyscrapers, its massive bridges spanning major rivers, and its enormous dams that had reshaped the landscape during the difficult years of the Great Depression. Now these same skilled hands would be tasked with building the infrastructure that would support the eventual Allied victory. Captain William Painter, a civil engineer from San Francisco who commanded the 47th Naval Construction Battalion during the war, would later document his observations in a classified report that captured the strategic significance of what the Seabees accomplished. In this report, he wrote about how the Japanese had based their entire defensive strategy on a fundamental assumption regarding the time required for base construction. They had calculated American advance rates based on what they considered to be traditional and realistic engineering timelines. What Japanese planners had never imagined, what they had never factored into their defensive calculations, was that American forces would be capable of reducing those construction timelines by factors of 10 or even 20 times what conventional military engineering would suggest was possible. The first truly stunning demonstration of Seabee capability came at Espiritu Santo in July of 1942. A relatively small detachment drawn from the 1st Construction Battalion arrived at the island on July 8th with what could only be described as minimal equipment for such an ambitious undertaking. Their inventory consisted of 6 tractors, 2 scrapers, 1 truck dedicated to carrying grease and lubricants, 1 wagon for gasoline transport, 3 weapons carriers for transportation and light cargo, and a single generator rated at 50 kilowatts. This modest construction force was supported by 295 infantrymen who would provide security, 90 Marines who would assist with defence, and 50 workers recruited from the local population who would provide additional labour. The strategic situation made speed absolutely essential. The Japanese airfield on Guadalcanal, located just 630 miles away from Espiritu Santo, was rapidly nearing completion. Allied forces desperately needed an operational base from which they could launch attacks against this Japanese position before enemy bombers based at Guadalcanal could begin threatening the vital sea lanes that connected the United States to Australia. The Seabees received orders that gave them 20 days to construct a runway measuring 6,000 feet in length, and this runway would have to be carved directly through virgin jungle terrain. They completed this seemingly impossible task in exactly the allocated 20 days, maintaining continuous operations around the clock despite tropical heat that was nearly unbearable and torrential rains that turned the construction site into a quagmire. The jungle they faced was so extraordinarily thick that sunlight could barely penetrate to reach the forest floor. Trees towering to heights of 150 feet had to be felled, a dangerous and time-consuming operation under any circumstances. After the trees were down, their massive root systems, which had anchored them for decades or centuries, had to be blasted out of the coral substrate using carefully placed explosive charges. Extensive swamp areas had to be drained through the construction of drainage systems. Hills that obstructed the runway path had to be levelled using heavy equipment operating continuously. Valleys that created unwanted depressions had to be filled with thousands of cubic yards of material. On July 28th, the 1st Fighter Squadron touched down on the completed runway. The very next day, B-17 Flying Fortress heavy bombers arrived and began using the base for operations. The crucial race for control of Guadalcanal had been effectively won before Marine forces even conducted their amphibious landing on that contested island. Lieutenant Commander Yasumi Doi, who served with the Imperial Japanese Navy's 11th Air Fleet, documented his observations in a report that would be discovered and translated after the war's conclusion. In this revealing document, he wrote about how Japanese planners had calculated that enemy forces would require a minimum of 3 months to establish functional air operations from Espiritu Santo. When American bombers actually appeared in the skies after only 3 weeks of work, Japanese intelligence officers assumed these aircraft must have been launched from aircraft carriers rather than from land bases. The possibility that these were actually land-based aircraft operating from a newly constructed airfield never seriously occurred to Japanese military analysts. Their entire tactical planning for the Guadalcanal campaign had been built upon assumptions that turned out to be completely false. The Japanese military establishment had substantial reasons for maintaining confidence in their construction timeline calculations. Their own construction efforts on Guadalcanal had required 2,524 men working continuously for 4 full months to build a single operational runway. This project had been regarded within Japanese military circles as a remarkable demonstration of Japanese engineering efficiency, particularly considering that it utilized forced labor drawn from Korea and Formosa, with workers dying on a daily basis from sheer exhaustion, from the tropical diseases that ravaged labor camps, and from severe malnutrition caused by inadequate food supplies. Despite this massive expenditure of human life and labor, the resulting runway remained unpaved, which meant it quickly turned into impassable mud during heavy rains, and it lacked proper drainage systems that would have prevented water accumulation. Japanese construction methodologies at this stage of the war still relied very heavily on manual labor, with individual workers carrying baskets of dirt and stones on their shoulders or backs, moving material one small load at a time in a process that was exhausting and desperately slow. German military observers, who were carefully studying Pacific military operations in an effort to understand American capabilities that might eventually be deployed against German forces in Europe, were equally skeptical of the reports they were receiving. Major Kurt von Tippelskirch, who had been assigned to analyze these reports for the German High Command, sent a cable to Berlin in September of 1942 that reflected the widespread disbelief among German military professionals. His message stated that Japanese reports regarding American construction capabilities in the Solomon Islands appeared impossible to reconcile with established and well-understood engineering principles. He suggested that these reports must represent either deliberate propaganda designed to deceive German intelligence or significant exaggeration by Japanese officers. His assessment insisted that no military force in the world possessed the capability to build operational airfields within the timeframes that were being reported from the Pacific Theatre. However, despite this German skepticism and Japanese disbelief, the reported timeframes were entirely accurate, and in fact they were about to become even more dramatically compressed. On Guadalcanal itself, after United States Marine forces successfully captured the partially completed Japanese airfield in their amphibious landing on August 7, 1942, the 6th Naval Construction Battalion immediately went to work on the captured facility. Despite facing nightly naval shelling from Japanese warships that would position themselves offshore and bombard American positions, and despite enduring daily bombing raids by Japanese aircraft operating from bases throughout the region, the Seabees had what would be renamed Henderson Field fully operational within just 6 days of the initial Marine landing. Even more remarkably than achieving initial operational status, they managed to keep the airfield continuously operational despite the ongoing Japanese attempts to destroy it. Japanese pilots began reporting with increasing frustration and confusion that craters created by their morning bombing runs, craters that should have rendered the airfield unusable for days, were somehow filled and completely repaired before their afternoon missions took off for additional strikes. The speed of these repairs seemed utterly impossible to Japanese observers who were accustomed to much slower repair timelines. A 500-pound bomb dropped on a runway would typically create a crater approximately 30 feet in diameter and 10 feet in depth, representing a massive disruption to flight operations. The Seabees working at Henderson Field would have such a crater completely filled with appropriate material, properly compacted to support aircraft weight and covered with metal matting to restore the runway surface, all within approximately 4 hours of the bomb's impact. During the intense naval battle of Guadalcanal that took place in November of 1942, Henderson Field was subjected to bombardment by Japanese battleships that fired massive 14-inch shells at the runway, creating enormous craters and apparently devastating damage. Yet despite this heavy naval bombardment occurring during the night, the runway was once again fully operational by dawn, allowing American aircraft to take off for missions against the Japanese fleet. Captain Toshikazu Ome, who served as operations officer for the Japanese Southeast Area Fleet, attempted to capture in his war diary the profound frustration that Japanese forces felt regarding their inability to permanently disable American airfields. He wrote that attempting to destroy American air bases was like fighting against the ocean tide itself. Regardless of how much damage Japanese forces managed to inflict on these facilities during night attacks or bombing raids, by the arrival of the next dawn, the airfield would be operating as though nothing whatsoever had happened. The Americans, he observed with a mixture of respect and despair, were capable of repairing damage faster than Japanese forces could possibly inflict it. The secret behind this remarkable capability lay not solely in superior American equipment, though equipment advantages were certainly significant, but rather in genuinely revolutionary construction methods that Japanese and German observers initially failed to fully comprehend or appreciate. The Seabees had perfected the tactical use of a material called Marsden matting, which was also referred to as pierced steel planking, and this material could create instant runways over coral substrate or compacted dirt. Each individual piece of this ingenious matting measured 10 feet in length and 15 inches in width and contained 87 precisely engineered holes that served multiple purposes. These holes allowed water to drain through the matting rather than pooling on the surface, and they prevented the buildup of mud that would otherwise make the runway unusable during rainstorms. The individual pieces interlocked with each other much like a giant jigsaw puzzle, creating a continuous metal surface. A single Seabee battalion working at full efficiency could lay 2,000 feet of functional runway in a single day's work. Japanese engineers, who were still constructing runways using the labor-intensive method of hand-laying individual stones to create a surface, required approximately 1 full month to complete what American Seabees could accomplish in a single afternoon of concentrated work. The Marsden matting represented just one innovation among many that the Seabees brought to Pacific construction. They had also developed highly effective techniques for crushing coral, transforming the Pacific's abundant coral reefs into perfect material for runway construction. Coral, when properly crushed into appropriate-sized pieces and then rolled to compact it, created a surface that was nearly as hard and durable as poured concrete. Mobile crushing plants that could be transported and assembled at new locations could process raw coral into usable runway material at a rate of 100 tons per hour. Japanese equipment, in those rare cases where such equipment existed at all, typically managed to process perhaps 5 tons of material per day, representing a productivity ratio of several hundred to 1. Chief Carpenter's mate Robert Stetson, who served with the 46th Battalion, described the typical Seabee operational process in vivid terms that captured the extraordinary speed of their work. According to his account, Seabees would hit the beach with the initial assault waves, landing alongside the combat troops. While Marine infantry were still actively engaged in firefights with Japanese defenders, Seabee bulldozers would already be running and beginning to clear ground. By D-Day +1, meaning the day after the initial landing, Seabees would have coral crushing operations underway. By D+3, just 3 days after the landing, they would be actively laying the interlocking matting for runways. By D+5, a mere 5 days after the invasion began, fighter aircraft would be landing on completed runways and beginning combat operations. Remarkably, this entire process would often be completed while Japanese forces were still falling back to their secondary defense lines, which meant that Americans would be servicing bomber aircraft for strikes against Japanese home islands, while enemy soldiers were still fighting on the same island. The equipment advantage that American forces enjoyed was absolutely overwhelming in its magnitude. A single D8 Caterpillar bulldozer, operated by a skilled Seabee equipment operator, could move approximately 1,000 cubic yards of earth, coral, or other material in one working day. This represented work that would have required 500 Japanese or Korean laborers working with hand tools to accomplish in the same time frame. American truck-mounted drilling equipment could blast through solid coral at rates that Japanese engineers, who were still using hand drills and hammers for most of their excavation work, found completely incomprehensible and seemingly impossible. The Seabees had specialized rooters, powerful machines specifically designed to rip entire trees out of the ground, removing root systems and all in a matter of minutes per tree. They had motor graders that could level an entire field in a matter of hours rather than days or weeks. They had heavy rollers that could compact coral or other material into surfaces hard enough to support the weight of fully loaded bomber aircraft. By November of 1942, intercepted Japanese military communications revealed growing panic among Pacific Theater commanders as they began to realize the true scale of American construction capabilities. Admiral Junichi Kusaka, who commanded the Southeast Area Fleet, sent a signal to Tokyo that captured the crisis Japanese planning was facing. His message stated that enemy construction capabilities exceeded all planning parameters that had been used to develop Japanese defensive strategy. The Americans, he reported, could build new facilities faster than Japanese forces could destroy them. He formally requested an immediate and comprehensive revision of all defensive timeline assumptions that had been incorporated into Japanese war planning. Tokyo's initial response to this urgent request reflected a deep skepticism and disbelief that pervaded the highest levels of Japanese military command. The Imperial General Headquarters initially refused to accept these field reports at face value, instead insisting that field commanders must be exaggerating American capabilities in order to excuse or explain away their own failures in preventing American advances. The German Kriegsmarine, which was monitoring Pacific operations carefully to understand American capabilities that might potentially be deployed against German forces in Europe, was equally stunned by what they were learning. Admiral Karl Dönitz, commander of the German submarine fleet, made an entry in his personal war diary on March 15, 1943, that revealed serious concern about the implications for European defence. He noted that American Pacific base construction reports, if these reports were indeed accurate rather than propaganda, indicated an engineering capacity that could potentially establish major port facilities on European invasion beaches within days rather than the weeks that German planners had assumed would be required. He concluded that the implications of such rapid construction capability for Atlantic Wall defence required urgent review by German strategic planners. The achievements of the Seabees continued to accelerate throughout 1943 as they refined their techniques and gained experience. On the island of New Georgia, Seabee units constructed an airfield at Munda while still under active Japanese artillery fire, with shells landing among the construction crews as they worked. The Japanese military had originally spent months building this airfield using their traditional methods. The American Seabees completely rebuilt and significantly expanded the facility in approximately 2 weeks of intensive work. On Vela La Vela, another Solomon Islands location, Seabee units constructed a fighter strip in just 10 days on terrain that Japanese engineers had officially declared to be unbuildable swampland that could not support airfield construction. The Treasury Islands operation in October of 1943 demonstrated yet another dimension of Seabee capability that would have seemed impossible by traditional military engineering standards. Landing in conjunction with New Zealand military forces, a detachment drawn from the 87th Construction Battalion began building a fighter airfield while the island was still contested territory with active combat ongoing. Japanese defenders, holding positions that gave them clear observation of the construction site, watched in mounting amazement as American bulldozers continued to operate even while under direct fire, with drivers protected only by armor plating that had been hastily welded onto their machines by Seabee metalworkers. The airfield became fully operational before Japanese forces had been completely driven from the island, meaning that American fighters were taking off to attack Japanese positions, while Japanese soldiers could still see the runway from their defensive positions. On Bougainville in November of 1943, multiple Seabee detachments drawn from the 25th, 53rd, 71st and 75th Construction Battalions came ashore with the 3rd Marine Division during the initial invasion. The Torokina fighter strip became fully operational on December 10th, slightly more than 1 month after the invasion began. The bomber strip at Piva was completed on December 30th. This represented work that Japanese engineers, using their established methodologies and timeline calculations, had estimated would require at minimum 6 full months to complete. The Seabees accomplished it in a matter of weeks, and they did so while under continuous enemy fire. The construction work at Bougainville took place under conditions that would have completely halted traditional military engineering operations. The entire area was essentially a vast swamp covered with dense jungle vegetation. Rain fell almost continuously, turning the construction site into a mud pit. Japanese artillery positions that had survived the initial invasion regularly shelled the construction sites on a daily basis. Enemy snipers specifically targeted equipment operators, understanding that killing or wounding the operators would halt construction more effectively than attempting to damage the heavily built machinery. Yet despite all these obstacles, the construction work never stopped or even slowed significantly. Seabees worked in continuous shifts around the clock, using powerful floodlights to illuminate the construction site at night. These floodlights naturally drew enemy fire, making nighttime work extraordinarily dangerous, but the lights allowed construction to continue through the night hours when traditional military operations would have halted. The transformation of the Mariana Islands during 1944 represented the absolute peak of Seabee achievement, demonstrating capabilities that even many American officers had thought impossible. On Saipan in June of 1944, the 121st Naval Construction Battalion landed directly with the initial assault waves, coming ashore alongside Marine infantry on June 15th, while Japanese defenders still held fortified positions overlooking Aslito Airfield. Under constant enemy fire, with Japanese tanks actually counter-attacking directly across the runway itself in desperate attempts to recapture their airfield, the Seabees began immediate repair work. 4 days later, the airfield was fully operational for American use. P-47 Thunderbolt fighter bombers were providing close air support to Marine units that were still engaged in intense combat less than 1 mile away from the runway. Captain Sakai Oba, one of the very few Japanese officers to survive the Battle of Saipan and live to tell about his experiences, wrote in his post-war memoir about the shock that Japanese forces felt witnessing American construction speed. The Japanese military had held Guam in their possession for 2.5 years, and despite this extended occupation, and despite numerous construction efforts, Japanese engineers had never managed to extend the runway at Guam beyond 4,500 feet in length. American Seabees, arriving after the invasion of Guam, extended this same runway to 6,000 feet in just 10 days of work. However, the island of Tinian represented the ultimate demonstration of Seabee capability, an achievement that seemed to defy the basic laws of physics and engineering. After the island's capture in late July of 1944, the 6th Naval Construction Brigade arrived with a mission that appeared utterly impossible even by the already extraordinary standards the Seabees had established. Their assignment was to build the world's largest airbase complex, and they needed to complete it in time to support B-29 superfortress operations against the Japanese home islands. The statistics associated with this project alone seemed completely fantastic to anyone familiar with construction. The plan called for 6 separate runways, each measuring 8,500 feet in length and 200 feet in width. The base would require hard stands, reinforced parking areas, for 265 B-29 superfortress bombers. Fuel storage facilities needed to accommodate 16 million gallons of aviation gasoline. Bomb storage facilities needed capacity for 30,000 tons of ordnance. Housing needed to be constructed for 50,000 personnel. All of this needed to be completed in under 90 days. The Japanese military had occupied Tinian for decades prior to the American invasion. Their own experienced engineers had officially declared that large-scale construction projects were essentially impossible on Tinian due to the difficult terrain conditions. The island was covered in extremely dense jungle vegetation that would need to be completely cleared. The landscape was riddled with an extensive network of caves that complicated construction. The island was composed largely of sharp coral that destroyed conventional construction equipment through rapid wear. The highest point on the entire island reached only 545 feet above sea level, but the terrain throughout was brutally difficult to work with. Additionally, thousands of Japanese defenders still hid in the extensive cave systems, emerging at night to conduct attacks on construction crews who were vulnerable while they slept or during shift changes. German intelligence officers, carefully studying captured Japanese engineering reports about Tinian, concluded that even with unlimited resources and ideal conditions, such an ambitious project would require a minimum of 18 months to complete. The Seabees completed all essential elements of this massive project in just 67 days of intensive work. Working 24 hours per day, organized into 3 separate shifts that rotated continuously, they moved 11 million cubic yards of coral and earth. To put this staggering volume into proper perspective, it was equivalent to excavating a canal that measured 10 feet in depth, 50 feet in width, and extended for 830 miles in length. They paved the runways using 900,000 square yards of asphalt that was produced on site using portable asphalt plants. They laid 20 miles of taxi strips to connect runways to parking areas and support facilities. They erected 1,200 Quonset huts, each of which could be assembled in just a few hours from prefabricated sections that arrived by ship. They built 6 miles of warehouses for storing supplies and equipment. They constructed workshops capable of performing complete aircraft overhauls, including engine replacements. They created the largest aircraft repair facility that existed anywhere in the Pacific Theatre. The construction techniques that the Seabees employed at Tinian were genuinely revolutionary and had never been attempted at this scale. Instead of clearing jungle vegetation by hand using axes and saws, which would have taken months, Seabees chained multiple bulldozers together in formations and simply drove these formations through the jungle at speed, clearing hundreds of acres per day by knocking down everything in their path. They used shaped explosive charges specifically designed to blast apart coral formations, creating instant quarries that provided construction material. They operated rock-crushing equipment continuously, 24 hours per day, producing aggregate material for concrete mixing. They assembled portable asphalt plants that could be made operational within days of arriving on an island, rather than requiring permanent installations. Commander Mitsuo Fuchida, the Japanese naval officer who had led the air attack on Pearl Harbor and was now assigned to analyze American military capabilities for Japanese High Command, wrote a devastating assessment in September of 1944. He stated that the enemy possessed construction abilities that rendered all Japanese defensive calculations utterly meaningless. The Americans, he observed, did not capture and gradually improve Japanese bases as Japanese planners had assumed they would. Instead, Americans created superior facilities essentially from nothing in less time than Japanese forces, required merely to dig adequate defensive positions. Every island that Americans captured became transformed into what was effectively an unsinkable aircraft carrier within days of the initial landing. Traditional defensive strategies that had been based on assumptions about construction timelines were completely obsolete and needed to be abandoned entirely. The German military establishment was learning remarkably similar lessons from captured intelligence documents and from reports provided by neutral observers who travelled between Allied and Axis territories. Major Hans von Luck, who was analysing American capabilities for Wehrmacht headquarters in preparation for the expected Allied invasion of Europe, submitted a report that reflected growing alarm about American construction speed. His assessment noted that if Americans could transform barren coral atolls into major air bases in approximately 2 months, then all existing calculations for European coastal defence would need to be completely revised. American forces, he predicted, would be able to establish secure beachheads equipped with operational ports and airfields before German reserve forces could possibly respond to halt the invasion. The Japanese Navy's desperate attempts to counter or slow down American construction speed proved completely futile. Operation Tan No. 2 in November of 1944 represented a specifically planned mission that targeted Seabee equipment and personnel on Ulithi Atoll. 24 Kaiten human torpedoes, essentially manned suicide weapons, were launched in a desperate coordinated attack designed to destroy bulldozers and other critical construction equipment. The entire mission failed completely without achieving any significant objectives. Within mere hours of this attack, Seabees had already repaired whatever minor damage had occurred and continued construction operations without any measurable interruption. Lieutenant Sekio Nishina, one of the engineers who had helped design the Kaiten weapons, wrote a final message before departing on his own suicide mission that captured Japanese despair about the construction imbalance. He stated that Japanese forces simply could not match American building capacity. For every airfield that Japanese forces managed to destroy through bombing or shelling, Americans would build 3 more airfields. For every bulldozer that Japanese forces managed to eliminate, Americans would land 10 more replacement bulldozers. Japanese forces, he concluded, were essentially fighting against time itself, and time consistently favored the Americans in every engagement. The impact of Seabee construction capabilities on Japanese strategic planning was absolutely catastrophic. Japan's entire defensive concept, known as the absolute national defense sphere, was built on fundamental assumptions about American advance rates. Japanese planners had calculated that each island fortress they constructed would require many months for American forces to reduce through combat operations and then rebuild into functional bases. This extended timeline would allow Japanese commanders to shift defensive forces between threatened points, concentrating strength where needed. Instead of this predicted pattern, Americans were building operational bases faster than Japanese naval forces could relocate between islands. The distance advantage that Japan had counted on was being eliminated by construction speed. Admiral Sumu Toyoda, who served as Commander-in-Chief of the combined fleet, admitted during post-war interrogation sessions the devastating impact of Seabee capabilities on Japanese strategy. He explained that Japanese war planners had designed a defensive strategy where both distances and construction time would work as allies for Japan. The vast expanses of the Pacific would slow American advances, while the time required to build bases would further slow their progress. The Seabees had effectively eliminated both of these advantages. American forces could build an operational airfield faster than Japanese ships could sail from one island to another. Japan's theoretical mobility advantage was completely negated by American construction speed that allowed bases to appear faster than Japanese forces could respond. The prefabrication revolution that Americans had mastered proved equally stunning to Axis observers throughout the war. Everything from individual buildings to entire harbour facilities arrived at Pacific Islands in numbered pieces that were ready for rapid assembly. Liberty ships carried what amounted to knockdown airports in their holds. A single ship could deliver everything needed to create an operational airfield, including runway matting sections, prefabricated control tower sections, collapsible fuel tank systems, complete repair shop equipment, barracks components, and even entire mess halls with working refrigeration units. A 100-bed hospital facility could be completely unloaded from ships, assembled on site, and made fully operational within 72 hours of arriving. Captain Wilhelm Doms, serving as German naval attaché in neutral Madrid, sent a report to Berlin after extensively debriefing Spanish merchant sailors who had observed American operations in various Pacific ports. His report captured German amazement at American industrial methods. He wrote that Americans had industrialized warfare to a degree that German military planners had never imagined possible. Americans were mass-producing not just weapons and ammunition, but entire military bases. Ships would arrive at remote islands carrying complete airports packed in numbered crates. Harbour facilities were assembled much like children's toys, with interlocking parts. The very landscape itself seemed to become a factory product that could be ordered, shipped, and assembled. The floating dry dock facilities represented this capability, taken to an almost unbelievable extreme. The Advanced Base Sectional Dock No. 1, known by its designation ABSD-1, was assembled at Espiritu Santo from individual sections that had been towed across thousands of miles of Pacific Ocean. When fully assembled, this floating dry dock could lift an entire battleship completely out of the water for repairs and maintenance. The completed dock structure was larger than any dry dock facility that existed in Japan, yet it had been created at an advanced base located 3,000 miles from Pearl Harbor. When the assembly was complete, the dry dock measured 927 feet in length and could safely handle ships displacing up to 90,000 tons. Japanese engineers, when they learned of this facility's existence, declared its construction impossible at such a remote location. German naval architects, studying intelligence reports about this dry dock, insisted that the reported dimensions must be propaganda exaggeration. Both the Japanese and German assessments were completely wrong. Captain Minoru Genda, who served as Air Operations Officer for the Japanese First Air Fleet, attempted to capture in words the profound psychological impact of American construction capabilities. He wrote that each American advance brought not merely warriors and weapons, but rather transported an entire industrial civilization to remote islands. American forces were not fighting simply to capture islands in the traditional military sense. Instead, they were systematically transforming each captured island into what was essentially a fragment of America itself, complete with all the infrastructure and capabilities that implied. The psychological impact on enemy forces proved to be every bit as devastating as the physical achievements of the Seabees. Japanese soldiers defending islands wrote letters home that, when captured and translated by American intelligence, revealed a growing sense of despair and helplessness. Private Shigeo Yamada, writing from his position on Peleliu, attempted to describe what he was witnessing. He wrote that the Americans appeared capable of changing the very earth itself. Mountains would disappear overnight through coordinated demolition and earth-moving operations. Swamps that had existed for thousands of years would become functional airfields within days. Dense jungle would transform into organized cities with streets and buildings. Japanese forces would prepare defensive positions expecting to hold out for months, but American construction allowed enemy forces to overcome these defenses in mere days. Yamada concluded that Japanese soldiers felt they were fighting against gods who possessed the power to reshape the physical world itself. This was not mere hyperbole or exaggeration born from combat stress. On Peleliu in September of 1944, Seabee units employed specialized reef blasting techniques that removed 35,000 cubic yards of solid coral in just 48 hours of continuous operations, creating a deep water channel in a location where Japanese military planners had insisted that no harbour could possibly exist due to the reef structure. They constructed a 6,000-foot bomber strip on terrain that Japanese engineers had officially declared unbuildable due to unstable substrate and poor drainage. They accomplished this using armoured bulldozers that continued working even while under artillery fire from Japanese positions. When equipment operators were wounded by shell fragments or sniper fire, replacement operators would climb aboard and continue the work without allowing the bulldozer to stop. On Iwo Jima in February of 1945, Seabee units faced what may have been their most difficult challenge of the entire Pacific War. The island was not composed of coral like most Pacific islands, but rather consisted primarily of volcanic ash, which made all traditional construction techniques essentially useless since volcanic ash would not compact properly. Japanese artillery forces had spent months carefully registering their guns on every square yard of potential airfield sites, meaning they could place accurate fire on any location where construction began. Casualty rates among Seabee units working on Iwo Jima reached 30%, extraordinarily high for construction troops. Yet despite these casualties and terrible conditions, Seabees had the first airfield operational while intense combat still raged across the island. A B-29 superfortress that had been damaged during a bombing mission over Japan made an emergency landing on the Iwo Jima runway on March 4th, while Japanese defenders still held fortified positions that directly overlooked the runway and could observe the damaged bomber landing. The German military attaché stationed in neutral Stockholm, who was studying American capabilities through intelligence sources available in neutral Sweden, sent a report to Wehrmacht headquarters in January of 1945 that revealed serious alarm about implications for European defence. He stated that if American forces could build operational airfields on Pacific coral atolls within days of landing, then they would certainly be able to establish beachheads anywhere along the European coast and render these beachheads effectively impregnable before German reserve forces could possibly respond. All traditional calculations regarding counterattack windows and timeline requirements were now obsolete. American forces, he warned, would bring their complete logistics infrastructure with them, arriving complete and functional rather than requiring weeks to establish supply lines. His assessment proved entirely correct. The same Seabee expertise and techniques that had transformed countless Pacific islands would soon be employed to construct the Mulberry artificial harbours at the Normandy beaches. These revolutionary portable harbours created instant port facilities on open beaches, accomplishing in a matter of days what German planners had confidently assumed would require the capture of established harbour facilities and many months of reconstruction work. The most profound impact that the Seabees had on World War II was their effect on the overall timeline of the war itself. Japanese war planners, working from what they considered reasonable assumptions about construction requirements, had calculated that an American advance from Guadalcanal all the way to the Japanese home islands would require between 8 to 10 years to accomplish, assuming that American forces would need between 3 to 6 months to reduce and rebuild each major base along the route. Instead, American forces reached the Mariana Islands within just 2 years of the Guadalcanal landing, placing B-29 Superfortress bombers within effective range of Tokyo and other Japanese cities years ahead of what Japanese planners had thought possible. This acceleration was not arithmetic, but rather geometric in nature. Each new base was constructed faster than the previous one, as Seabee units continuously refined their techniques and learned from experience. Construction operations that had required 20 days at Espiritu Santo in the early stages of the war required only 10 days at Treasury Islands as techniques improved. By the final stages of the Pacific War, runways that had required weeks to complete in 1942 were being finished in a matter of days by 1945. The final Japanese assessment, prepared as the war drew to its conclusion, was devastating in its honesty about Seabee impact. Commander Chikao Yamamoto, in an intelligence report prepared before Japan's formal surrender, wrote a comprehensive analysis of why Japanese defensive strategy had failed so completely. He stated that Japanese forces had prepared for a war where distances and time would favor the defender. The Americans had succeeded in eliminating both of these advantages. American construction battalions had achieved things that the best Japanese engineers had declared physically impossible. They had built functioning civilization faster than Japanese forces could destroy it. Every calculation, every assumption, every defensive plan that Japanese military planners had developed was systematically invalidated by American to transform any piece of earth into a fully operational military base before Japanese forces could possibly respond to the threat. The statistical record compiled by the end of the war told a story that was impossible to refute or dismiss. Seabee units had constructed 111 major airstrips scattered across the Pacific Theatre. They had built 441 piers to support naval operations and cargo handling. They had erected 2,558 ammunition magazines to safely store explosives and ordnance. They had constructed 700 square blocks of warehouse facilities. They had built complete hospitals with capacity to serve 70,000 patients simultaneously. They had installed storage tanks with capacity for 100 million gallons of gasoline and other fuels. They had constructed housing facilities sufficient for 1.5 million men. They had conducted operations on more than 300 islands across 6 continents. They had moved more earth and material than had been excavated during the entire construction of the Panama Canal, one of the greatest engineering projects in human history. And they had accomplished all of this extraordinary work while under enemy fire, in hostile environmental conditions, at speeds that pre-war engineering manuals and textbooks had declared physically impossible. Post-war analysis by military historians revealed even more stunning statistics that demonstrated continuous improvement. The average time required to construct a 5,000-foot fighter strip dropped from 60 days in 1942 down to just 10 days in 1945. The average time needed to build an 8,000-foot bomber runway dropped from 90 days early in the war down to 30 days by war's end. By 1945, Seabee units could establish a completely functioning port facility equipped with multiple piers, extensive warehouse complexes, and complete fuel storage systems in approximately 2 weeks from initial landing. Japanese forces, even when they had access to unlimited labor supplies, typically required 6 months to create similar facilities using their construction methods. Lieutenant General Yoshitsugu Saito, who commanded Japanese defensive forces on Saipan, wrote a final message before committing suicide as American forces overran his positions. In this message, he attempted to explain to higher command why his defense had failed. He stated that enemy power lay not primarily in their numerical superiority, though American forces did enjoy numerical advantages, but rather in their seemingly supernatural ability to appear anywhere and transform literally nothing into fully functional bases with impossible speed. American forces were not merely occupying territory in the traditional military sense of taking and holding ground. Instead, they were recreating territory in America's image virtually overnight, transforming alien landscapes into American installations with astounding rapidity. Field Marshal Erwin Rommel, while conducting his inspection tour of Atlantic Wall defences in 1944 in preparation for the anticipated Allied invasion, had warned his staff officers about the implications of American construction capabilities. He told them that if American forces could build operational airfields on remote coral atolls in a matter of days, as intelligence reports indicated they were doing routinely in the Pacific, then they would certainly establish secure beachheads on European shores before German forces could possibly react with effective counterattacks. Rommel predicted that construction speed, not movement speed, would ultimately determine the outcome of the next phase of warfare. Both of these commanders, Saito and Rommel, were entirely correct in their assessments. The Seabees had not merely built military bases in the traditional sense of that term. They had fundamentally reconstructed the very nature of modern warfare itself. They had proven conclusively that in modern industrial conflict, the speed of construction could prove more strategically decisive than the speed of destruction. Every Japanese defensive timeline, every German calculation of American capabilities, every assumption about what was physically possible in warfare had been systematically buried under millions upon millions of cubic yards of crushed coral that had been laid down by American men who possessed the knowledge and skills to both build and fight with equal expertise. Admiral Matome Ugaki, who served as Chief of Staff for the Japanese Combined Fleet throughout much of the war, wrote in his final diary entry before departing on his own suicide flight on August 15, 1945, a remarkably honest assessment of why Japan had been defeated. He stated that American forces had not defeated Japan through superior strategy or superior tactics, though American strategic planning had certainly been competent. Instead, Americans had defeated Japan with what he called superior reality itself. American forces possessed the capability to create the seemingly impossible and then make such impossible achievements routine and ordinary. Against such overwhelming capability, all traditional forms of military planning became completely obsolete and irrelevant. The German assessment of American capabilities, prepared after the war's conclusion, was equally sobering in its recognition of what the Seabees had achieved. Colonel General Franz Halder, who had served as chief of the German General Staff earlier in the war, wrote a comprehensive post-war analysis of American military capabilities. He observed that Americans had successfully mechanized construction in the same way that Germans had mechanized warfare itself through the Blitzkrieg concept. However, where German Blitzkrieg tactics had ultimately reached their operational and logistical limits, American construction capabilities had seemed essentially infinite and without apparent limits. Americans had not defeated terrain obstacles, weather challenges, or vast distances through superior tactics. Rather, they had simply ignored these obstacles entirely and built directly through them as though such obstacles did not exist. The official motto adopted by the Seabees was simply, "can do," just two words that captured their attitude and approach. In the vast Pacific War that stretched across millions of square miles of ocean, those two simple words had rewritten the fundamental mathematics of military possibility itself. They proved beyond any doubt that American industrial genius could be effectively deployed not merely in factories back home, but directly on invasion beaches, in hostile jungles, and across coral atolls thousands of miles from American shores. The war in the Pacific Ocean was certainly won through the bravery and sacrifice of Marine infantry, through the courage of Navy sailors manning warships, through the brilliant strategic planning of American commanders, and through the skill and courage of Army and Navy pilots. However, all of these combat achievements were made possible by Seabees, who built functional civilization at combat speed, proving conclusively that in modern industrial warfare, the power to create could ultimately overcome any power to destroy, no matter how devastating that destructive power might be. The legacy left by the Seabees was written not in traditional battle reports or combat after-action summaries, but rather in countless tons of crushed coral and in thousands of sections of steel matting, in the runways that appeared seemingly overnight where virgin jungle had stood the day before, in bases that materialized from solid jungle as though by magic, and in the increasingly stunned and desperate reports filed by enemy commanders who discovered far too late that the Americans had successfully weaponized construction itself. The Seabees had made the impossible become routine and had made the routine become utterly unstoppable. They had not simply built bases across the Pacific. They had built victory itself, accomplishing this one impossible runway at a time, one base at a time, transforming the Pacific Ocean from a vast defensive barrier protecting Japan into a highway for American victory.